This is Ron. I have a new lamp circuit I'd like to show you. This is my new lamp driver circuit. It's a circuit meant for a wheelchair type battery, deep cycle battery, to run lamps using LED bulbs. The LED bulbs I found are the 8.5 watt bulbs. I'll show to you in a minute. They only consume 0.1 amps or 100 milliamps. And I'm using a new type of transistor, very powerful. It's this guy right here, the 7337, much more powerful than the 3055 I've been using. And I have a specific coil I've wound just for this type of battery, this bulb, and this transistor. And this bad boy with two bulbs will give me 5.4 hours of running time. This is my hand wound transformer that's doing all the work. 600 winds of 28 gauge wire, and on the outside is 45 turns of 22 gauge wire. And this is extraordinarily efficient. You can see my hand in comparison to that thing. It's not that big, just a few inches across. Generates a lot of power. That's about a 9-to-1 coil. That is, my 12 volts is going up to about 108 volts AC. So this transistor, this very powerful transistor, this is the kind in audio circuits. If you buy a home stereo, this is what's going to be in it. 2 of these will drive a 120 watt amplifier. 8 of these in configuration goes up to 2,000 watts if you want some high powered audio. I put one of these on a heat sink that I made out of a spare piece of aluminum, and this keeps it cool. And all this circuit does is this transistor gets driven by the coil and vibrates at about 3.7 kilohertz, which makes any AC device turn on. Doesn't just have to be 60 cycles. A whole bunch of cycles will work just as well. So what I have done is I've hooked up my little circuit here, and I've attached 2 leads to the AC plug that would normally go on the wall. And let me hook this baby up to the battery here. It's hard to look at the camera in my hand at the same time. And this circuit will very neatly drive this bulb with this LED 8.5 watt bulb, 120 volts. And this particular light gives a very nice, true omnidirectional light. The camera keeps compensating, but if you can see, the light is shining down below towards the paper here. It'll also give a nice shine on the side of my hand, so it's giving a nice light exactly like our old-fashioned bulbs would do. And of course I can drive several bulbs with this circuit. It'll handle 2 nicely. What I'd like to point out also about this circuit is a lot of people have been having trouble with their transformers squealing like little pigs. That's because you're using an E-core transformer. Notoriously inefficient. They'll constantly suck more energy than a toroid. An E-core will suck down about 300 milliamps even when the circuit's not running. This one will suck down only about 40 or less. And all the magnetic energy is concentrated in the center, so it does not ring. I get no heat out of this whatsoever. What I do notice is this transistor, very powerful. When you put a lot of lights on the circuit, it will ring. Because this heat sink I have, a piece of aluminum, is almost like a speaker. That little baby is vibrating very quickly, turning the circuit on and off. and the frequency goes down when I add more light bulbs. And this acts as a speaker. And I can just barely hear a little ringing right now. But if this were boxed up, I don't think you would hear anything. Like when I pick it up, it disappears. When I put it down against the wood, it kind of drives the wood. You can just about hear that little ringing sound. So I think once I box it up, I'll put some insulation in there to keep it keep that little ringing down. So that's my new circuit. It depends on LED bulbs, which in the past have been notoriously expensive. Extraordinarily expensive. So let me show you where I got this light bulb from. This ETI 8.5 watter. It does a superb job. I've been replacing the bulbs in my house, and in previous videos you've seen lights be yellow. These are true white lights. They're only 3,000 Kelvin in degrees, which means it's very close to the light we're used to. It's just white instead of yellow. I think that also helps with the perceived brightness. So I got this from 1000bulbs.com, and it's the 8.5 watt LED bulb here. Gets very high marks. It's really good. It says it's a 50 watt equivalent, but I would put it closer to 60. It's very bright to my eye, and right now it's only $6 for a bulb. As I've said in the past, these bulbs are hellaciously expensive. I've seen 60 watt equivalent bulbs be as high as $40. They do last for 30,000 hours, but even at that amount of efficiency, there's no way of paying that much for a light bulb. But $6, I can swing $6. This baby's going to last me 5 years if I use it 12 hours a day. Okay? That's going to last me a while. My Curly Q CFLs, I've boxed them all back up because I bought a lot of these bulbs. I've been testing these out. And a big curly bulb, like this guy here, is 26 watts. And I would not put it any brighter than that bulb right there. Plus, there's lead. There's a lot of circuitry in here that contains lead. The top is filled with mercury. And this is actually an ultraviolet light. And there's phosphorus inside the curlicue that turns the ultraviolet into infrared light. So if you lose this phosphorus coating, you can get burned by the light. Also, I have this particular circuit, which you've seen as the Tesla aerial. I have measured that circuit. That is, I've used that circuit to measure the output of light with this antenna. I've shoved this antenna right up into my can lights here with CFL bulbs in it, and I read as high as 6 volts in 20 seconds, which means that there's a lot of radio frequency energy coming from this type of bulb into your living space. I mean, a lot of high frequency energy. It contains coils to stop that, but still, it's an awful lot of energy when you're around 20 to 30 feet from these things. So I'm replacing them. Also, this bulb is, let's see what it's rated at here. This bulb is rated at 350 milliamps. I doubt that severely. I would put this closer to 500 milliamps actual usage. I think they're really dreaming with 300 because I've actually measured these, and these are actually 100 milliamps each. So the idea here is to match this specific battery to specific lamps and make a specific coil so I can drive lamps in the house. If I convert to these bulbs, which I already have, all I got to do is box the circuitry and I can plug in my lamps and run them with a battery. And the battery I'm using is a universal battery. It's a 12 volt 18 amp battery. Now I want to say one word about battery usage too. If you're going to use it to light your house with, you can't use all the energy that battery hints at there. So it's an 18 amp battery I have. If you notice, there's a efficiency constant here. You cannot use 100%. Well, I'm sorry, that one's for the rating. The way they rate a battery, you can only count on 90% of the energy in that battery. So I actually have a 16.2 amp battery. My lamp there takes 0.1 amps draw. So, and also there's a safe discharge rate. You cannot discharge a battery fully. In fact, you can barely get to half your battery. So I use 0.6 there. And my coil turns voltage, or I should say amperage, into voltage. So I'm sacrificing some of my amperage to run that at 120 volts. So my real runtime for a bulb off a battery that's rated at 18 amp hours is actually about 11 hours of actual runtime. So that's something you have to take into account if you plan on running a house off of batteries, which I may get to someday. But in the meantime, it's just a hobby. So with the efficiency of these new bulbs, we can at least light our houses successfully with batteries. Also, it's the reason why I built the Bedini pulse motor, so I have a way to recharge my batteries without plugging them into the wall. In case we lose electricity, I can charge up batteries using my Bedini pulse motor, and that is not over unity, it's just highly efficient. So when I get to that point where I need more energy, I can use the sun. I have a solar panel here that's 17 volts, 200 milliamps in the sun. It's enough to give enough of a charge to one of my batteries to run this motor to charge something more robust. So I have a whole system worked out now where I have a chance of running my house, at least the lighting, from just a few batteries. So that's my story. And there's my circuit again. And again, this thing runs with so little heat, I can actually hold on to the heat sink. It's a bit warm, but not uncomfortable. So, low heat, huge efficiency, and able to charge it off the grid. That's what I've been working at. This is me. See ya.